Hello everyone, welcome to the channel IGCSE and GCSE Maths School. Today too we are going to discuss some questions of the paper 1H Edexcel IGCSE January 2023. Already we have done 3 videos discussing questions up to question number 10. Now today your discussion opens with the question number 11, right? Question number 11 is Cartesian plane with several straight lines drawn here, and they have given us a shaded region R. Then we are asked to find then they have given the equations of these lines. They have drawn 3 lines. Here one line, here another line, and here another line. There are 3 lines given. Then we are asked, we have been given 3 equations of 3 lines also, but they haven't specified the equation with the particular line. But we have to find the equation attributable to each line, and then write the inequalities defined in this shaded region, right? Then to find inequalities, we have first of all find which equation of which line. That is the thing we have to find. We have to find which equation goes to which line. What is the equation of this line? What out of these 3 equations can be attributable to this line? Then what out of these 3 equations is attributable to this line? What out of these 3 equations is attributable to this line? Right, like that. Then we have to first of all identify the equations of each line. How do we do that? I think that to do that, these critical points, this is y-intercept, here there is x-intercept, here also there is x-intercept, here there is some point here, right? Some point on this line, coordinates of point on this line, that is -1, -2, right? Then they will be helpful for us to know that. But there we can use another property of straight line, that is gradient property. Gradient property also helps sometimes to understand the equation of the line, right? Which equation goes to the particular line, right? Okay. Now let's see, take this one. Now here, you know, if you draw a Cartesian plane here, this is y-axis, this x-axis. Then line are directed in this way, are all positive gradient. These have positive gradient, positive gradient, positive gradient. The lines which are directed in this way have negative gradients. Keep in mind, negative, negative, negative. These are negative lines, negative gradient lines. Now out of this here, there is one line with positive gradient in the graph. So these 2 lines have gone like this. These 2 lines have negative gradients. So I told you the lines going like this have negative gradients. Then here there's one line with positive gradient, line going like this. It's a positive gradient. Then there's one. Then see, therefore, accordingly, these 3 equations are the 3 equations of 3 lines. Then out of these 3, there must be 2 equations with negative gradients and 1 equation with positive gradient. We will first of all find that, right? To find that, I will take this equation. I will take this one, equation 1. Let's say 3, 5. Then I will take equation 1 here, 1. Then I take 2x plus y equals 6. Then we can have an idea about the gradient. Some measure about the gradient by making y the subject. Then you adjust this into the general form of equation, y equals mx plus c. If the equation is in the general form y equals mx plus c, this m is the gradient. Then what we are going to do is to see what the gradient is by transposing this for y, otherwise making by the subject, and otherwise adjusting that, rearranging that in the form y equals mx plus c. Right, then make y the subject here, take that to that side, then it will be -2x plus r. This is a negative gradient, see. Now here m is, now it has been converted into the form y equals mx plus c. Now m value is the coefficient of x. This coefficient of x is minus 2. Then here negative gradient. We can write negative gradient line. The negative gradient. Right, then second one. Then second one, 2y. Say 2y equals 5x plus 1. 2y equals 5x plus 1. Then you make y the subject. Even without making y subject, now we can do it here. Y equals 5 over 2x plus 1 over 2. Right, okay. Then here negative again, it has also been transposed for y. Otherwise, say y has made the subject, I has been made the subject. Otherwise, so it has been converted into this form, general form y equals mx plus c. Then for coefficient of x is the gradient. Then here the gradient 5 over 2, that is positive. Then this is a positive gradient, plus gradient. Positive gradient, right? Positive gradient. That is positive gradient. Then third one. Third one we'll try. Third one is 3y plus 2x. 3y plus 2x equals 4. Then here also, this one also is converted into this form now, and see what is the value of gradient. Then you make y 3y, no? This is 3y. Right. They make 3y the subject first equals then 4 minus 2x. Then y equals 4 over 3 minus 2 over 3 x. And this one also negative gradients. A coefficient of x is here. This is the intercept. Coefficient of x is 2 over 3. That is negative gradient. This is also negative gradient. Right. Negative gradient. Right. Okay. Now see. Okay. Now by using these properties, I think we can identify this equation. This equation 2x plus y has a negative gradient. Then and its intercept is 6. Its intercept 6 minus 2 intercept is 6 means this one then. Because this line gradient negative gradient line goes like there are two negative gradient lines in this graph plane. This one and this. Out of this the intercept is 6. Here. Intercept is the y coordinate, the point at which the graph cuts the y axis. That is 6. Otherwise y value when x is 0. Then it is 6. Therefore this is the equation. This one is the equation for this. I have to write the equation here. 2x plus y equals 6. Right? The next one. The other one, the other negative gradient one is there. The only positive gradient, only one equation has positive gradient. That is nothing but this one. That's a very obvious that. Then you can write 2y equals 5x plus 1. Then the other one is this negative gradient. Other negative gradient graph is this one because only two negative graphs. So one has been found. The other equation left is third one. That is applicable to only this other negative gradient line left. That is how much? This one 3y plus 2x equals 4. 3y plus 2x equals 4. Right. Okay. That is the, now we have attributed the equations to lines. Okay. Right. We attributed the equations to lines. Right. Okay. Now then we can write the inequalities. Right. Now see, now these are all hard lines. They are all what you call solid lines. There are no broken lines like this. Therefore, always the inequality when there are inequalities, when the inequalities are represented on graph plane, if the solid lines have been drawn, then the inequality is always less than and equal, less than and equal, more than and equal. If there are solid lines, like not a broken line, the continuous lines. The continuous lines or solid lines are there always inequality less than and equal, more than and equal. Right. Okay. Then we will write this one. Then now take the region which is into this triangle. Now you are going to define the find the inequality defining this shade of region. Now take this inequality, this one. Then always inequalities on always when you mark inequalities on a graph plane, below the line always y less than, above the line always y more than. Here again this line. Then below the line, y less than. Above the line, y more than. Then this one below the line, y less than. Above the line, y more than. It's very easy way to remember. So therefore, now from this line, now take from this line, which region is taken into triangle? From this line, there are two regions into which this plane is divided by this line. Then that one area is below the line, other region is above the line. Then what is taken into the triangle? The triangle is situated in the area below the line. So therefore, y less than. Y less than. Then you have to take this y less than this one, this area. Y less than y. Sorry, we can write that 2x plus y less than or equal 6, because what is that called? This solid line. Okay, from this one, this side. Right. That is one inequality. The other line is this one. This one again below the line. The triangle is below this line. Therefore, below this line, y less than. Therefore, you can write like this: 2y less than or equals 5x plus 1. Because less than or equals because it is a solid line. Okay, from this line also like this. Right. This is. Then this one. Take this one. From this line, what has happened? Triangle is above the line. That means triangle is in the region above the line. Region above, y more. Region below, so 2x plus 5 less than or equals 6. This one also 2y less than or equals 5x plus 1. Okay, right. Below the line, right. Now from this one, y is above the line. Triangle is above the line. Therefore, inequality region must be region above the line. Above the line, y more. Therefore, you write here from this one. From this one. What is that? 3y plus 2x more than or equals 4. Right. Okay. Here are the inequality region. Now we write the inequalities. What are the inequalities defined in this? One is 2y less than or equals 5x plus 1. Other inequalities were 2x plus y less than or equals 6. Other inequalities were 3y plus 2x, 3y plus 2x, 2x greater than or equals what? 4. That is the answer. 3 inequalities defined in this region. Okay. Right now, next question. Just stop the video and watch again and again and try to understand. So, if you have any problems, write in the comment section. I will again clarify this by doing another video. Okay. Right. Now the 12th one. 12th one is like this. 12a. They say like this. 3 to the power half into 3 to the power 205 equals 3 to the power m. Right, okay, now we see. Now this is again what? They have given two indices of the same base to be multiplied. When you multiply indices of the same base, powers added. Then you add this half and 2 over 5, half and 2 over 5, that is how much? Half and 2 over 5, how much? This is 10. 10 is the common denominator, then it's 5 here, then this 1 over 2, 4, then it's 9 over 10. Okay, so that is the sum of the two fractions, right? That is the addition of the two fractions. Then it will, you can write this as 3 to the power 9 over 10. Okay, right? Then equals 3 to the power m. Then 3 to the power m. Then here, when you have when the two indices of the same base are equal, two indices of the same base are equal, the powers can be equated. When the two indices of the same base are equal, powers can be equated. Therefore, here 3 to the power 9 over 10, 3 to the power m. Therefore, we can write what m equals how much? 9 over 10. If the bases are equal, powers can be equated. If the bases are equal, powers can be equated. If two indices of the two indices are equal, right? If two indices are equal, if two initial statements are equal and they are with the same base, the powers also must be the same, right? The principle applies. Now next one. Then 12b. Then 12b. What is 12b? 5 to the power minus 10 plus divided by, right? They like this. They say 5 to the power minus 10. 5 to the power minus 10 divided by 5 to the power minus 4. 5 to the power minus 4, right? Okay. Now they say equals 5 to the power n. 5 to the power n. They ask us to find value of n, right? Now you can write this also very easy, because when you divide the indices of the same base, powers are deducted. Then 5 to the power minus 10 divided by 5 to the power minus 4 equals 5 to the power n. Then when you divide this power of the denominator is deducted from the power of the numerator, then you can write minus 10 minus 4 equals 5 to the power n. Then we are getting that here, this when you multiply this by minus by the plus, then it will be minus 10 plus 4 equals 4 to the power n. Then you can write this as 5 to the power minus 6 equals 5 to the power n. Then again the same thing. If the two indices of the same base are equal, powers are equal. If the two indices of the same base are equal, powers are equal. Therefore, n equals minus 6. Okay. Then that is question 12, right? Question 12. Then go to question 13. Q13. What is Q13? They ask you to expand this 3x, 2x minus 5 to the power 2, right? Okay. Then power 2, then 3x. We'll expand this first of all. They asked us to expand this. Then what we do here, when you expand, this is a perfect square. This is a square of difference. It's square of sum of two terms. So it's square of difference. When you expand this, this one square, 2x square, then then this into this into 2. That means minus 5 into 2x into 2. You multiply these two and multiply that by 2 again. You multiply these two and multiply that answer again by 2, right? Then another one is what? Minus 5 what? Minus 5 square. That is that. That is the expansion of that. We will simplify that. 3x equals here 4x squared. Here minus 5 to minus 10 into 2 minus 20 minus 20x. Then this one plus, because minus 5 into minus 5 is minus 5 means x squared means minus 5 into minus 5. Then it will be 25 plus 25. When you multiply two numbers of the same sign, they become positive. The directed number rules. There's videos in the playlist directed numbers. Go and see. We have discussed all those direct number rules, right? Okay, then 2x, 3x. Then you multiply by 3, that remove brackets. 3 times 4x, then 3 times 4, 12, then x into x squared will be x cube. Then 3x into 20x, 3 into 20, 60, the x into x squared. Then 3x times 25, 25, 3 times 25 is 75 and x. Oh, that is that. 12x cubed minus 60x squared plus 75, right? Okay. With that, today's video is ending. The rest of the questions for this paper will be, can be discussed in the next video. Until next video comes, say goodbye to you. Thank you very much for watching until the end.